Hello, Algebra 1. Today we are reviewing for our Unit 10 test on solving quadratics in different ways. So the first way we're going to practice solving is by taking square roots. We're going to give exact answers. So for number 1, we will start off by getting the x squared by itself. So we'll subtract 9 on both sides. And we'll get x squared equals negative 9. And now, since the x squared is all by itself, I can root both sides. But wait, that's negative underneath there. We can't take the square root of a negative, and so this is just no solution. All right, so let's try another one. Our first step will be to subtract 10 on both sides. And we'll get negative 2x squared equals negative 40. Now, we can't square root both sides yet. We need to get the x squared by itself. So don't forget to divide by a negative 2. And that is going to give us a positive 20. Now we can go ahead and root both sides, and we'll do a factor tree with our 20. So 20 breaks down to 5 and 4, and 4 breaks down to 2 and 2. Since we have a pair of 2's, our 2 is going to come out of the root. And since our 5 does not have a pair, it stays underneath the root. Make sure you have that plus or minus, because remember there are 2 solutions for these. All right, so now let's try some that have some parentheses. When you have parentheses that are being squared, the first step is to get the parentheses by themselves. So we can't distribute this 3 because of our laws of order of operations. So instead, we'll divide by 3 to get rid of it. 75 divided by 3 is 25. And now that the parentheses are by themselves, I will go ahead and root both sides. That's going to cancel our squared and bring down our x plus 8. Square root of 25 is plus or minus 5. All right, make sure you have that plus or minus. And now we'll just subtract 8 on both sides. Okay, now be careful here. This is saying positive 5 minus 8, which is negative 3, or negative 5 minus 8, which is negative 13. So there are 2 different answers here. All right, let's try one more like that. This one is similar, but we are going to add our 2 over first. We don't have anything multiplying to our parentheses, so we will not need to worry about that. 16 plus 2 is 18. All right, next I'm going to go ahead and root both sides. But 18 is not a perfect square, so I am going to have to do a tree for this. So I'm going to do, let's see, 9 and 2. And 3 and 3. So I'm going to not forget my plus or minus, and I have a pair of 3's and a 2 that does not have a pair. So 3 comes out, 2 goes under the root, and finally we're going to subtract that 4 over. Now remember that 4 can't combine with a root, so we're just going to put it in front. Negative 4 plus or minus 3 root 2. All right, so that's solving by square roots. Next, we're going to solve by completing the square, which also involves solving by square roots. Now, when you just have a 1x squared, this is a little easier than when we have a number in front of our x squared. Just as we saw with factoring, there are extra steps. But the first step is always to move your constant over to the other side. Okay, so I'm going to add 15 over. And it might help to leave a little space right here, because now what we're going to do is complete the square. So we take our b value, which is that 10, we're dividing it by 2, which gives us 5, and then we're squaring it, which gives us 25. And we are going to have to add that to both sides. Now we're going to take this guy and we're going to factor it. What multiplies to 25 and adds to 10, that's 5 and 5. Again, we've talked about this. It's always this number right here that it's going to be. X plus 5 squared equals, combine your like terms on the other side, and we will get 40. And now this is just like a problem that we had above. Okay, we're going to go ahead, we're going to root both sides. Bring down your x plus 5. We'll do your tree over here. So notice we have a pair of 2's. 5 and 2 do not have a pair. So I'm going to bring out my plus or minus, my 2, and then my 5 and 2 will multiply to give me 10. And finally, just like we did in the last problem, we'll subtract our 5 over. but because it cannot combine, it's just going to stay in front here. Okay, like so. All right, now let's try it again, but this time we have a number in front of our x squared. So you're going to start off with the same step. You're going to move your constant over to the other side. So I'm adding over 44. Now, before I complete the square, there's a very important step. I'm going to divide out or factor out my 4 here. Okay, so when I do that, make sure you divide the 4 out of each term. Okay, and now we're not going to divide the 44 by 4. We're just dividing these first 2 terms here. And now we're completing the square with this term. So negative 8 divided by 2 is negative 4. Square it is 16. All right, but here's where you really need to be careful. I'm not adding 16 to this other side because I really didn't add a 16. I actually added a 16 times 4. So what I really added was a 64. Okay, so that's going to counteract that 64 that I added over here, even though I know it looks like I added a 16. Now I'm going to factor. Again, we're always going to use this number right here. So this is x minus 4 squared. Those are the numbers that multiply to 16 and add to negative 8. Combine your like terms over here, and we get 108. Okay, and now remember, we can't root this yet because we've got this 4 in front. So we're going to divide by the 4. And that is going to give us a 27. And now we can root both sides. And we will do our tree. And we have a pair of 3s and a 3 that's left out. So x minus 4 is equal to plus or minus 3 root 3. And then finally we're going to add that 4 over. But again, you can't combine it, so it's going to stay in front. And it'll look like this. All right, so now we're going to start moving on to quadratic formula and vertical motion model. Identify the values of a, b, and c from the following equation. Now remember, you shouldn't identify a, b, and c until you're in standard form. We did this when we were in factoring as well. So the first thing we're going to want to do is add our 10x over, and your x should always go in the middle. That's your b value. All right, so this is my standard form. So my a should be negative 4, my b should be positive 10, and my c should be 8. And let's see here, negative 4, 10, 8, that should be this guy. All right, evaluate the discriminant. Given 4x squared minus 12x equals negative 9, how many solutions does the equation have? Okay, again, if you're going to evaluate the discriminant, we need to be in standard form. So we're going to start off by adding our 9 over. And it is just a regular number, so that's our c value. It'll go at the end. And now I can go ahead and do the discriminant. So b squared minus 4, my a is 4, and my c is 9. And when I type that into my calculator, I actually get a 0. Okay. So my solution, or my discriminant is 0. This actually means I have one solution, so it is a. All right, next we're going to talk about quadratic formulas. So we're going to put these ideas of number 7 and 8 together. So once again, remember with quadratic formula, you have to be in standard form. We're going to add over our 44x. And we're going to subtract over our 56. And we want to make sure all of these are in the correct order. So the 3x squared is going to come first. The 44x is going to come second. And then you have this negative 56 and this negative 40, which will combine to give you negative 96. And then we have our equal 0. Now you can identify your a, b, and c values. All right, here we go. Quad formula. X equals opposite b. So that's a minus 44, plus or minus the square root of b squared minus 4. My a value is 3, and my c value is negative 96, all over 2a. So 2 times 3. All right, next I'm going to go ahead and evaluate the discriminant, which again is this part right under here. I'm going to use my calculator, which I should have had loaded, but I didn't. It's coming. Could have paused the video and got it running, but we're just rolling with this. Okay, here we go. All right, so we have a 44 squared minus 4 A and C. Make sure you have the negative 96. And we get 3,088. Over 2 times 3 is 6. All right, finally, we're going to type this into our calculator 2 different times, once with the plus and once with the minus, in order to find our two solutions. Okay, and what we have learned throughout this whole unit, don't forget to divide by 6, is that these solutions that we have gotten, all of these represent our x-intercepts, or our zeros, of our parabola. Okay, so I rounded there 1.93. And now I'm going to do this whole thing again. Oops, this time with a minus. Don't forget to divide by 6. Negative 16.59. Okay, so both of those, if we were to graph these would be where your zeros are, your x-intercepts. All right, last two. We have our vertical motion model problems. An acorn drops from a branch 70 feet above the ground. If it hits you in the head 5 feet above the ground, how long did it take the acorn to drop? Okay, this just has a starting height and an ending height. There's no velocity here, so I'm going to use drop. The starting height of the acorn is at 70, the end height is at 5, and then I'm just going to go ahead and I'm going to plug my numbers in here. So 5 equals negative 16t squared plus the starting height of 70. All right, so I'm going to do one of these with my calculator and one of these with Desmos. I'm just going to use Desmos for this one, and I'll use the calculator for the next one. So when you're using Desmos, you're going to type y equals 5, and y equals the negative 16t squared. You could use x squared if you want. It doesn't matter. Desmos is not picky about that. And then what we're looking for is where we have our intersection points. We can see that we have two. We have one here at 2.02, and we have one at negative 2.02. But again, we always want the positive version because this is representing time. So t is just, that's not what I wanted, 2.02 seconds. Okay. Mrs. Stites, that's me, goes up to the roof of a plane and throws a football with a downward velocity of 15 feet per second. That does not seem very safe. I don't think I would really do that. She throws the football from a height of 40 feet. How long does it take the football to hit the ground? All right, well, let's find out in this very unlikely scenario. This one does have velocity. That means we're going to use our throw equation. The starting height of the football is 40. The ending height is the ground, so that is 0, and it is a downward velocity, so make sure you have negative 15. All right, so again, we're going to use the second equation right up here. So we have end height equals negative 16t squared plus vt, so that's a minus 15t. Make sure you have that t, that's the one people forget, plus your starting height of 40. Okay, and this time I'll use my calculator. Oh, gotta be in the right mode. Okay, so let's start over again. This time I'll use my calculator. So my y1 is just going to be 0, and my y2, I type everything else in. And then I'm just going to go ahead and press graph. And I'm going to change my window so that we can actually see it. And in order to find the intersection point, we just press second, trace 5, enter, enter, enter. And we'll get 1.18 seconds. Again, I just worry about the positive one here. And if you were to use Desmos, you would get the exact same thing. So there you go. That's your review for your test tomorrow. I hope you have a wonderful day. Bye.